Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Sayyid Ali. Today we have another word problem, and the question is the path of the Jimli after is tossed by the argon can be modeled by the function h is equals to minus 2.5 t square plus 15t plus 1.5, where h is the height of the Jimli in feet and t is the time in seconds. A part, how long did it take for Jimli to reach to its maximum height? How long will it take to reach it to the maximum height? It's like fired, is a shot, right? So Jimli is a kind of fire or shot. It is thrown from tossed or throw. Tossed means throw. By argon is a kind of gun. So it is shot from a gun and it goes high up, and the question is asking how long does it take for the Jimli or the shot to reach to the maximum height. How long means time, right? And it is a function of h and t. So that means there are two things, h and t, right? So how long means this is your time, right? How long? This is your time. How long will it take? How long will it take to reach to the maximum height? This is your height and this is your t. How long will it take to reach to the maximum height? So when it's maximum height, it's the time. This time is unknown, right? How long will it take to reach to the maximum height? So it's a function of h and t. So instead of x and y, now we have h and t. So how long will it take to reach to the maximum height? Part B, what is the maximum height? And determine when the Jimli will be at the same height as he was when he was tossed. So there are three parts and we will do one by one. So we have a part and we have that equation, right? So we have to make the perfect square thingy from out of it. So minus 2.5 t square plus 15t plus 1.5. This is the equation, right? And we know that if we want to make it a perfect square, what we do? We do 2.5 common. So t square minus 6t, right? Now we have to see that how we can make it a perfect square. We always take half of it and square. So make a half of it. So 6 over 2, half of it and square, right? And if we add this thing, then we have to subtract the same. So 6 by 2 whole square. I make another bracket so that it is clear, plus 1.5. Now we are making it perfect square. Minus 2.5 will remain outside. T square, or we can say that this is the whole square of t minus 3. This is 2. 6 by 2 is 3, right? T minus 3 whole square. But this thing is extra. What is that? This is 9. Minus 9. What is this minus 9? Minus 9 is here. 2 3 it cuts, adds 3 and then square, right? So it's 9 plus 1.5. We have 1.5 here. Minus 2.5 t minus 3 square minus 9. But minus 9 is not minus 9. We have to multiply it with minus 2.5, right? So it becomes 22.5 plus 1.5. So 22 plus 22.5, right? 22.5 is of plus. Right? Because it is here 2.5 times this, right? So when you times it by minus plus, so this 2 will be added up. So minus 2.5 times t minus 3 whole square plus 24. And this equation, which we make as a vertex form, is telling me everything, right? It tells me that if T is equals to 3, the bullet or the gimli, right, the fire, gimli will be at maximum height. This is first answer. And second part, but we have to calculate maximum height. So when it achieves maximum height at T is equals to 3. So we have to plug in the value. Plug in T is equals to 3. So if we want to plug it in, then we will be having minus 2.53 square plus 1.5 times 3 plus this was 15 times 3, 15 times 3 plus 1.5. If you simplify it, it comes out as 24. So if we plug it in, we get the value of h. H is equals to minus 2.5 t square, minus 2.5 t square plus 15t plus this, right? So we have our maximum height. Maximum height is equals to 24, right? And we can also determine it from here, but we have to do it like how we substitute it. So it's a 24 meters is the maximum height. This is your maximum height, H-E-I-G-H-T. So in how many minute, in how many, it was minute or second? Seconds. It was seconds, right? So in 3 seconds, it was in the maximum. So it is in the second. He says in the second, right? So it is in the second. So H is equals 24 meters is the maximum height. And what is your C part? This is your B part. Now is your C part. What is C part? C part is determine when gimli will be at the same height as when it was shot or tossed. When it was tossed, so when it was tossed, you can answer it directly if you want to, because when it was tossed, T was 0, so it was at 1.5. So it's direct, but you can also answer it with like H and K value. So it also gives you 1.5, right? If you make it a partial factoring, it's also called partial factoring, or you can directly answer it from the main equation that if T is equals to 0, we have H is equals to 1.5. When it was tossed, it was at the height of 1.5 meter. But what partial factoring means is that if you have this portion, y is equals to minus 2.5 t square plus 15t, right? And then you can take out common is minus 2.5 t, then you are left with t minus 6. So that means this thing becomes 0 if we have t is equals to 6 or t is equals to 0. So t is equals to 6 or t is equals to 0, we make everything 0. T is equals to 6 or t is equals to 0 or 6, right? If you substitute t is equals to 6, height will be same as the initial height. At t is equals to 6, height will be same as of the initial height. So what was the initial height? Initial height was t is equals to 1.5 meter. 1.5 meter. So this is by partial factoring, but you can also answer it with the help of the main equation that when it was fired, it was at t is equals to 1.5. It was the initial, right? But at t is equals to 6 means as it was fired, it was here, t is equals to 6, and now it is on this, right? So these both are same, which are this is your t is equals to 6 and height is same. At t is equals to 6, it will be at the same height. And what was that height? It was 1.5 meters. So hope you like the video and you understand it thoroughly. Just do it one more time so that it is clear every step. and then you can explain it. You can pause the video and do it by yourself, and then you can see my answer of the solution. So it's like a word problem, and it's a quadratic function. So it's a h and t function. So you know that when it is fired or shot, it achieves a maximum height in certain time, and then it drops back to normal, drops back to its original. And three questions are here. How long did it take to Gemini to reach to the maximum height? So it was 3 seconds to reach to the maximum height. And what is the maximum height? So we substitute back into this 3 seconds into this equation, and we calculated that maximum height is 24. And then determine whether Gemini will be at the same height as was when it was tossed. So when it comes back at 6 seconds to the ground, it is at the same height, which is 1.5. Hope you like the video. If you like it, subscribe my channel and press the bell icon button to receive another video. Thank you for watching.